Okay, reporting live from my favorite place in the world, the driver's seat. Seems to be the place where I could really film all my content and then edit it as the baby naps on me. First, a few updates on the car before we get into the how-to CAD video. One, do not try to lift a vehicle off a trailer by yourself. Don't do it. I managed to give myself an actual hernia from all that jerking and twisting and pulling that I was doing. So learn from my mistakes. I will not be doing anything physical on the car until well after I get some surgery to patch myself back together. But that said, I did manage to make some progress. I went to the DMV and it took 3 trips and a lot of back and forth with different paperwork, but the car is now titled and registered under my name, which is really exciting. I was kind of losing faith in that for a second, wondering if I got ripped off, but everything worked out in the end. So now that the paperwork is set, I can go full speed ahead on this project. So I think in a separate video, I'll do like what my plan is for the project, projected costs and all that. But I think regardless of which direction I go in, I'm gonna need a free chassis and jig. Took a little bit of relearning and reacquainting for me to get used to using CAD, but I'm slowly figuring it out. And I wanted to kind of just show you a live process of one, me remembering how to use CAD, figuring out Fusion 360, which is free for personal use. And then two, the process of taking those factory dimensions and turning them into a 3D fixture that you could use to straighten out your car and build upon it. Hopefully you can gather some insight from this video. It's kind of long, but I think it's fun. It'll be fun for me to look back on and see the process, see how I've improved in CAD since then. So, gonna cut to the CAD video now.
Okay, we're going. So here's me trying to figure out Fusion 360 for the first time. I'm going to make a torsion bar support, so I'll save that in this new Porsche jig project. I have no idea if this is saving locally or on the web, but maybe we'll just start. Okay, I've brought over some materials, all the different factory dimensions. I figure a good place to start is this torsion bar support because it's pretty easy to see. The bolt pattern is defined well. The center of the torsion bar is defined well enough relative to the zero plane here. I think the one thing that I'm going to have to dig through is just to see how much space I have in the y-axis. So the y-axis goes side to side in cars. X-axis goes forward and backward, and the z-axis goes up and down this direction. I think I'll start with just the hole pattern. I may even need to find out what this radius is on the outside here so that I know how much clearance I need to give to whatever's over here. I think the body kind of comes out like in towards the screen in this view. All right, so let's get started. Okay, so the back view is what would be the side view in a car. So we're going to create a new sketch. We're going to create it on the back view. Okay, we're going to make a circle. It's going to be over here. Actually, that's not true, is it? It's below the zero plane by 42 millimeters. Okay, so we're just going to, not do that. Okay, so now I've got my select tool, so I can just grab this center point. There we go. And add a dimension here. Oh, there we go. Okay, and this is going to be a 42. Okay. And now we know that this hole is going to be not defined there, not defined there, defined here. So this is the zero plane. Up at the front here, this is going to be 1774.65 plus or minus 2 whole millimeters. Now, do I remember that number? No. 1770.65. Okay. And then we hit enter. And now that hole should really have run away from us. Yeah, there it is. Okay. And then we also need to, we've located where the hole is. Now we need to define the size of the hole. So we go over here. It's not defined there, is it? That would be way too convenient. Okay, maybe it's this one. It's not letting me pinch to zoom. Okay, the hole is not defined there either. It's not defined here. We get a depth though, that's kind of cool. Is it defined here? Here. Wow, started off really confident. Okay, so we can just kind of eyeball it and then I can measure it later. Seems like it's pretty well aligned to this 60 millimeter dimension of the distance between these two bolt holes. And then these bolts are actually hopefully around the center plane, this 13-degree center line, or is it 30 degrees? Well, I saw that on the dimension. Okay, so we're going to say this hole is 60 millimeters. And then I'll go measure it on the car later. Okay, so there it is. We're going to say 60. Wow, look at that. How does that look? Pretty good. Pretty good. Okay, so now we got this reference line, which should be 13 degrees. If we go over here, oh, I see what it is. It's 13 degrees and 30 minutes. 13 degrees and 30 minutes. Because why wouldn't it just be exactly 13 degrees or 14 degrees? Okay, and there are how many minutes in a degree? I'm pretty sure there's 60. Okay, now how do I make a reference line? Circular pattern. Maybe if I just make a line and then I say this line needs to be a construction line. Yeah, okay, so there's that line. And maybe actually I should delete the coincidence. Okay. So we're gonna try that line one more time. We're gonna make it like this. We are going to make it a construction line, and then we're gonna add this constraint that makes it coincident, this dot and this line. So now move this line around. Yeah, buddy. Okay, so now I'll just make it a little bigger so it's easier to grab. We are going to dimension this to the z-axis. Okay, so we get to do something fun, which is finding out. Maybe if I just make another line here, this one. A construction line. So now, there we go. So then 13 point, I think that's good enough. What do you think? 13.3 degrees is about 13 degrees and 30 minutes. And, you know, we have way more significant figures than what I am going to end up doing when I make this part on my drill press or, you know, really template it off of, you know, the original part. Okay. So we have that. Now we have these holes. There's holes here. There's holes here. They seem to all be centered around this hole. So I think I need to make another reference line degrees to that other one. This is all just kind of, you know, trial and error. Okay. So this one, I think if I hit X, yeah, here's the shortcut. Okay. And then we say that this is going to be coincident. This dot and this. And then we just say it's 90 degrees. I'm sure there's like a wrong way to do that. Okay. And then we create some holes. We have holes here. We have holes here. Okay. We're going to say each one of them is equal. Okay. All right. We have this one's 140 about that axis. This one's 100 on that axis. Okay. Is there like a center line type thing? Symmetry. Symmetry. Okay. And then we have another symmetry. Nope. Maybe it's the way that I selected it. Symmetry. 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 So if we hit select, what will that do? What are we trying to do? Okay, so these are good. These are good. Okay, so now I think I can just put that 140 dimension in there. Yeah, buddy. 140 and then 100 and 60. Okay. Unfortunately, won't work. We're going to stop being fancy and we're just going to say this is 30 because that's what's going to or something down the line, you know, find that that's easier. Okay, so now these are still, I mean, I guess they're all defined. The only thing left is just the size. Okay, and we don't know the size. We're going to pretend like those are M8. What if those were the dimension here? Then we're going to say that's 8 millimeters. That seems too small. Okay, we're going to pretend like they're 10 millimeters for now. And now this whole thing is actually defined. Oh, the bolt pattern. So now I need to find out what the dimension is here. Okay, that's something I'm going to have to measure on my car. But just for the purpose of this video, we're just going to like create something cool. This 90 degrees here. Okay, we're actually going to just make rectangle. We're going to dimension this thing. We're going to say instead of 70, it should be 60. And instead of whatever this is, it should be 30. And then this could be 30 as well. And this could be 30 as well. And then if we're doing that, then we might as well just do it over here too. 30 millimeters to the closest hole. And then we make a chick fillet. They wanted me to define that. So 40 looks pretty good. I want to see what 100 looks like. 100 looks great. Okay, finish the sketch. We're going to just rotate this around for you. We are going to extrude this, and it is going to actually be two sides. Yeah, it will. Okay, so now we need those X dimensions, which are not here. Are they here? Yes, they are. So it's 1079 divided by 2 to get you to the edge. See, 1079. Okay, And we'll do the outer edge first. So 10, we're going to do 1100 divided by 2. And oops. Okay. How do I do that? So I made my cool extrusion, but I need to edit it because I hit enter. We'll just do it again. Okay. So extrude 2 sides. This thing. Okay. 1100 divided by 2. Okay. And then negative 1079 divided by 2. That should do it. That's going to create this thing. So there is the first piece, which, has accurate bolt pattern, but the holes are the wrong size. This outer shape needs to be confirmed, but that's what we got. It's pretty exciting. Okay.